So, I'm going to give another presentation. This one is about the Younger Dryas Impact Hypothesis. If you talk about a lost civilization, there's got to be some reason why it got lost, something major. And that's why the Younger Dryas Impact Hypothesis is of great importance to me. After my presentation, Dr. Alan West from the Comet Research Group will join me, and we will have a discussion about the work of the Comet Research Group and the challenges that they face. So, I shall begin. As I mentioned earlier, in my work, going right back to the early 1990s, I began to see the period of around 12,500 to 13,000 years ago as being incredibly important to the ancient civilizations that I was dealing with. And it seemed to be associated with some kind of cataclysm, but I didn't know what it was. And I looked at a number of possibilities, and one of the possibilities was indeed the Earth crust displacement theory by Charles Hapgood, which gets a very solid mention in Fingerprints of the Gods. But there are a number of problems with that theory. If that theory were correct, and I'm not totally ruling it out, if it were correct, it would be an utterly devastating global cataclysm if the Earth's crust were to shift. But then, in the 2000s, particularly since 2007, I came across the Younger Dryas Impact Hypothesis, which was then a new hypothesis. And I realized that the cataclysmic incident that I was convinced had taken place between around 12,500 and 13,000 years ago was exactly being described by the Comet Research Group, that this is what they were focusing on, a global cataclysm, precisely of the kind that could have wiped a civilization from our memory. So I want to talk a bit about the YDIH, the Younger Dryas Impact Hypothesis. It is not a fringe hypothesis. Everybody behind the Younger Dryas Impact Hypothesis is a solid, massively credentialed scientist. We're dealing with people who are absolutely mainstream scientists, but they are taking a position involving catastrophes. And something about science, particularly geological sciences, they don't like cataclysms, they don't like catastrophes. And the Younger Dryas Impact Hypothesis has faced a huge amount of very bizarre attacks upon it over the years from other scientists who seem to want to get rid of it for some reason. So look, this is our home, the Milky Way. We're in the Orion Arm, and we're orbiting the center of the galaxy at about 515,000 miles an hour. Just consider that. We don't have that sense. I mean, we know the Earth turns, but we are actually in orbit around the center of the Milky Way galaxy at 515,000 miles an hour. And look at these figures. There's the 514,000. But the Earth is spinning on its own axis at 1,000 miles an hour if you're at the equator. 1,000 miles an hour. We're sitting on something that's running at 1,000 miles an hour. And it's going around the Milky Way galaxy. So it takes 225 million years, despite that vast speed, for our solar system to make a complete circuit of the center of the Milky Way. So we've had about 20 galactic years since the Sun and the Earth first formed. Now here's the funny thing. The Earth's orbit around the center of the Milky Way is not on a flat plane. The Earth does this. The whole solar system does this kind of sinusoidal motion as it orbits around the center of the galaxy. And it has been suggested that this motion, as we pass through the central plane of the galaxy every 27 or 30 million years, puts us into a dense and dangerous area of the galaxy where we're much more likely to receive comet impacts than we would at other times. And there is a theory that these 27.5 million year cycles are a result of that interaction with the dense central plane of the galaxy. And there's been a lot of good science published on this. I think it's very interesting. It suggests that mass extinctions events on Earth may occur roughly every 27 to 30 million years, potentially linked to the solar system's passage through the crowded midplane of the Milky Way galaxy. The scientific work was done by Rampino and co-authors. They note that the solar system passes through the midplane of the galaxy approximately every 26 to 30 million years. They speculate this could cause increased encounters with dark matter, disturbing cometary orbits, and so on and so forth. So where do comets come from? There are two main sources. One is the Kuiper belt, and the other is the Oort cloud. What this cycle seems to show is that we have these periodic showers of comets that come in from the solar system's Oort cloud, come in from deep space. It's a kind of junkyard of icy bodies. Both the Oort cloud and the Kuiper belt are thought to be sources of comets. It's very likely that the comet that was responsible for the Younger Dryas impacts was a comet that came in from deep space, was attracted by the Earth's gravity and by the sun's gravity, and went into orbit around the sun. Unfortunately, an orbit that crosses the orbit of the Earth. And comets are they're not just dirty snowballs. Comets are full of masses of rock as well. Let's take Comet 67P, photographed by the Rosetta probe. There's its nucleus. The nucleus of a giant comet can exceed 200 kilometers in diameter. And the scientists working on the Younger Dryas impact think we're looking at a comet that was originally at least 100 kilometers in diameter, that came into the inner solar system and started to disintegrate. To give you an idea, that's 67P overlaid on San Francisco. Needless to say, an impact with such an object would be utterly devastating. And we've been observing comets in the solar system for quite a while. And the one that teaches us very important lessons is Comet Shoemaker-Levy 9, which hit Jupiter in 1994. The massive gravity of Jupiter caused this comet to break up into multiple fragments. In fact, it broke up into 21 fragments. You can see some of them here, these glowing, deadly trails of light. And when they smashed into Jupiter, Jupiter drew them in with its gravity. Total explosive power of the Shoemaker-Levy 9 impacts, 300 gigatons. A gigaton is equivalent to 1 billion tons of TNT. I nearly said DMT. 1 million tons of DMT. I mean, can you imagine? Bring it on. The stockpiled nuclear arsenal of the entire Earth, were it to explode at once, would be equivalent to just 6.4 gigatons. So we're talking just enormous explosive events. This is the moment. I've talked about this before, and I'll say it again here. Thank you, Jupiter. We owe everything to Jupiter. Jupiter is the giant guardian of our planet. With its huge gravity, it is drawing in comets that would otherwise have made life on Earth completely impossible. So Jupiter is our protector. And Jupiter's so big, Jupiter can take it. Not a problem. If one of those things hit the Earth, we'd be done for. Yeah. So, of course, the biggest impact event that we all know about, that's still in current discussion, is the so-called KT, or the Cretaceous Paleogene event, as it's now called, that made the dinosaurs extinct at the Cretaceous Tertiary boundary. You can see that boundary. It's a boundary layer, and there's a huge extinction follows it. These days, there's quite a lot of thought that the object that made the dinosaurs extinct wasn't an asteroid, it was a comet. That is still an argument, it's still a theory. Whether it was a comet or an asteroid, we know what it did, and what it did was massive. the world changed utterly. The former order of things was swept away, and a new order began to emerge. So the dinosaurs aren't quite extinct. That fella down there, that's a dinosaur. The birds survived. These guys vanished, but the birds survived. They are dinosaurs. And then why am I showing you this little shrew here? Purgatorius. Well, that is because that's our 65-million-year-old mother. The mammals were going nowhere during the age of the dinosaurs. They were dead in the water. But when the dinosaurs were gone, the mammals suddenly began evolving and stepping into niches that previously had been unavailable to them. And that was the beginning of mammalian evolution that fundamentally led to us. So, yes, it made the dinosaurs extinct, but we're here. It changed the world completely. Now, that's called the Cretaceous-Tertiary boundary, or the Cretaceous-Paleogene boundary, as they've renamed it. You can see that it's a very distinct boundary layer in the rock, and it's full of what are called impact proxies. They're full of the evidence that there was a cosmic impact, even though there may not be a crater immediately visible in the area. These include iridium, carbon microspherules, nanodiamonds, shocked quartz, melt glass, suicide and other minerals melted at extremely high temperatures, more than 2,200 degrees centigrade, the boiling point of quartz, across a wide area of the Earth's surface. And here's Luis Alvarez and his son Walter Alvarez at the KT boundary. They faced exactly the same kind of bullshit that the Comet Research Group is facing today. They couldn't produce a crater initially, and the scientific community turned on them, savaged them, sought to destroy their reputations, said they were making it all up, it was false, it was wrong, it was fraud, it was a hoax, but it wasn't. It was real. And they did eventually find the crater. And that crater is the Chicxulub crater in Mexico. It's deeply buried beneath the Gulf of Mexico, shown up in remote scanning. Since then, it's not been an argument anymore. We know why the dinosaurs went extinct. NASA tells us that these extinction level events occur only once every 100 million years. I wonder what magical frequency NASA are dialing into to say that the 100 million year intervals. Obviously, if there's 100 million year intervals, we don't need to worry. You know, I mean, the last one was 60 million years ago. We got 40 million years. Why should we care? But a number of eminent astronomers say we should care very much indeed, and that our cosmic environment is much more active than NASA teaches us, and they're particularly concerned with comets. And I'm showing Fred Hoyle, Chandra Wickram Singh, Victor Klube, and Bill Napier here. This is a NASA fact sheet. What is a meteor shower? Well, every single meteor shower, whether it's the Taurids, whether it's the Orionids, whether it's the Leonids, every single meteor shower is what's left of a disintegrated comet. It's the dust trail of a disintegrated comet, and as the dust enters the Earth's atmosphere, it burns up, and we see shooting stars. And they say, not to worry. Meteorites are usually small. They almost always burn up quickly in the atmosphere. Little chance they're going to strike the Earth's surface. Just see a beautiful shooting star show. The message is, don't worry. But the prominent astronomers who disagree say we should worry very much indeed, that the Earth is orbiting in the trail of a giant destroyed comet. And several times in the past 13,000 years has suffered cataclysmic bombardment from bits of cometary debris. And that's had profound implications for history. There's always been a fear of comets. Going right back into human history, there's this terror of comets. That omen in the sky seems to presage danger. And you have to ask yourself, why should that be so? The Taurid meteor stream, as was explained earlier, we call it the Taurid meteor stream because at the moment, as a result of precession, if you look at the sky, the radiant, the point out of which the Taurid meteor stream appears to emerge is in the constellation of Taurus. It isn't coming from the constellation of Taurus. That is just a visual illusion. That's the bit of the sky that it appears to be coming from, and that's why it's called the Taurid meteor stream. The Taurid meteor stream is 30 million kilometers wide of cometary debris. Some bits of it are just dust, and some bits of it are very large, including Comet Encke. If you read the mainstream coverage of this, they'll tell you that Comet Encke, what's left of it, was the source of the torrid meteor stream. I disagree, and so do most of the scientists working on this. Comet Encke is one of the fragments of the original very large comet that was broken up in the gravitational field of the Earth and the Sun. And then Olgiato Rudnicki, 19 of the brightest near-Earth objects that are several kilometers in diameter, are in the torrid meteor stream. It takes the Earth several days to pass through the torrid meteor stream. It's so big. The torrid meteor stream is full of filaments of debris. Some of those filaments are very small debris. Some of them are much larger debris and much more dangerous. We pass through it twice a year. I've likened it in the past to strapping on a blindfold and crossing an 8-lane highway and just hoping that you don't get hit by a truck. Let it be a motorcycle at least, rather than a truck. And that's the origin of the torrid meteor stream. There's two parts of it, the beta torrids. They're encountered in June and July. And then you have the torrids in November, which are sometimes called the Halloween fireworks. So we cross the torrid meteor stream in June, July, and we cross it in October, November as well. And it's pretty clear, and again this was touched on I think by Randall earlier, that the Tunguska event, this cataclysmic airburst over Siberia in 1908, fell out of the beta torrids. That the 30th of June 1908, the date of that impact, is the peak of the beta torrids. It would be most extraordinary if this wasn't a torrid object. But it exploded in the atmosphere, technically an airburst before reaching the ground, and this is the effect. It exploded in the sky at an altitude of about 5 to 6 kilometers. Date was the 30th of June. The object is thought to have been about 60 meters to 190 meters wide. That airburst was utterly cataclysmic. It flattened 80 million trees across an area of more than 2,000 square kilometers. That's an area larger than London. This thing, if this had exploded in the sky over a major city, we would all be very concerned about the torrid meteor stream right now. It's just a lucky accident that it exploded over a completely uninhabited area of Siberia in 1908. If it had exploded over a major city, that whole city would have been wiped flat. It would be gone. So the astronomers have been looking at the sky, coming to the conclusion that we're looking at the debris stream of a fragmented giant comet through which we pass twice a year. Other scientists, Comet Research Group, have been looking at the ground and making disturbing new discoveries. This is Bill Napier. He's one of the astronomers, and he's just drawing attention between the astronomical information and the terrestrial information. And he's referring to a catastrophe of celestial origin, which has been postulated to have occurred around 12,900 before the present. That's the Younger Dryas Impact. And the reference to a catastrophe of celestial origin refers to the work of this team. Alan West is with us. He'll be joining me on stage shortly. James Kennett, Richard Firestone, James Whittaker, Albert Goodyear, Christopher Moore, and 60 others, major scientists in their field, highly respected individuals who are convinced from the evidence that the Earth was hit not by a single object, but by multiple objects, a sort of shotgun scatter of objects, many of which blew up in the sky, some of which probably hit the North American ice cap. And they've presented compelling evidence for that. If you look at the world during the last ice age, you can see North America, particularly the northern part of North America, was covered in an ice cap 2 miles deep. So also northern Europe. Sea level was 400 feet lower than it is today. Why? Because all that water was in those frozen ice caps. Here's the graph of the last phase of the ice age. The last glacial maximum generally put it around 20,000 years ago, approximately, when the last glaciation reached its maximum extent. Then after that, the world did begin to warm up, and it warmed up quite politely and quite gradually. And it must have been glorious for the people in the world, particularly in high latitudes, to see that warming effect. But then suddenly, around 12,800 years ago, global temperatures just rocketed down, and they went back to the same level that they were at the peak of the last ice age. And then you have 1,200 years of extremely cold weather. This is the period when all the great megafauna go extinct. And then, around 11,600 years ago, the world suddenly warms up again. Very dramatically, very suddenly. And that period of 1,200 years, that's called the Younger Dryas. That's the name that's given to it, after a particular kind of alpine flower that flourishes in cold conditions. So we're looking at a huge extinctions of the megafauna, both in North America and in South America and in Europe and in Siberia, all over the world. That this was a cataclysm of radical climate change, there's no doubt about that. Nobody disputes that. But the question is, what caused it? What caused the cataclysm? Why did the climate change so suddenly? What happened? And the explanation that's given by the mainstream on this really begs further questions. What is said is that there's a thing called the global meridional overturning circulation, of which the Gulf Stream is a part. It's a flow of warm and cold water currents that travel around the whole of the world ocean. And the Gulf Stream in particular plays a very important role in keeping the northern latitudes warm. And the suggestion is, the mainstream view is, that there was flooding out of glacial lakes on the American mainland, and that this flooding of cold water interrupted the overturning circulation, the kind of central heating system of our planet, and caused our planet to get much colder. Now, there's no doubt that is the mechanism, but the question is, why? Why was there so much meltwater released into the world ocean that it could actually stop the Gulf Stream dead in its tracks? And that's a question that the mainstream has never satisfactorily addressed, in my view. But what is clear is that at the beginning of the Younger Dryas, at the very moment when the world is suddenly getting cold, something really weird happens. Sea levels rise suddenly. There's a dramatic pulse of sea level rise. It's not an enormous rise. It's 2 to 4 meters within a few decades or less of YD onset. Why is this puzzling? Because we are entering a period of deep freeze. In a period of deep freeze, you'd expect the ice mass to grow and sea levels to fall. You wouldn't expect the ice mass to carve off huge amounts of water, dump it into the world ocean, and cause sea levels to rise. But that's what happened. That's fundamental. What triggered those meltwater discharges? And I think the answer is very clear. Those meltwater discharges were triggered by fragments of that disintegrating comet hitting the North American ice cap. And Randall is absolutely right. Hitting a 2-mile deep ice cap, they're not going to leave craters that are visible, but they are going to produce an enormous amount of water that's going to rush into the world ocean. And you can see from the diagram on the right the spread of the evidence that we now have for what's called the Younger Dryas boundary, where these proxies of impacts are found in the soil all around the world, heading all the way from the far west of North America as far east as Syria. Basically, the Younger Dryas boundary contains exactly the same impact proxies that were identified in the case of the KT boundary. And we can look at it here. There's Murray Springs on the left. You can see the Younger Dryas boundary. It's about the hand's width in size. And again, all over the world, Gainey, Michigan, Lommel, Belgium, iridium, nanodiamonds, sedimentary layers in Murray Springs. It's just all over the world. I'm with Alan West here at Murray Springs, and he's showing me the black mat. This is referred to as the black mat. This is where the primary evidence for the Younger Dryas Impact Hypothesis is found, because that black mat is full of the proxies that could only be caused by airbursts or impacts from an extraterrestrial object. And actually at Murray Springs, this is the excavation of Murray Springs. They're excavating a mammoth there. They gave her a name, Eloise. And that black mat was found draped over her body. That mammoth died in the Younger Dryas impact. And I'm not going to try and read these papers to you. I just want to show you that the Comet Research Group is an extremely serious group of people who have faced unwarranted opposition from other scientists and who are bringing very important information to the field and are doing so in the right way. They're publishing that information in peer-reviewed journals. And it just goes on and on and on. The evidence that they have brought forward, and at the same time the sneering dismissal of other scientists towards that evidence, that is also part of our fight for the past. I'm just going to show these images from different scientific papers that's been published by the Comet Research Group to make it clear to you that this is scientifically well-established data. This is not fringe data by any means. Journal of Geology, 2014, July 2015, large platinum anomaly in the Greenland ice core points to a cataclysm at the Younger Dryas. That's the Proceedings in the National Academy of Sciences. It's there in Nature's Scientific Reports. We have biomass burning, Younger Dryas cosmic impact, 12,800 years, of a possibility of evidence of impact proxies even as far south as the Antarctic. And in fact, the 2014 YDB strewn field of impact proxies has been traced across 50 million square kilometers. But the studies from May 2018 reporting impact proxies in Antarctica's Taylor Valley also linked to the evidence of an impact airburst 12,800 years ago. We're gradually seeing how global this event was, what huge parts of the world that it affected, and the fascination with finding a crater is completely ignoring the nature of the event, that this was largely airbursts of the Tunguska type that took place all around the world. Patagonia in Chile, Abu Huraira in Syria. This is a really fascinating site. It's so close to Göbekli Tepe. And the evidence for a massive airburst there around 12,800 years ago is absolutely compelling. Indeed, there's a map. You can see Abu Huraira and Göbekli Tepe just a couple of hundred miles further away from Abu Huraira. I think the event at Abu Huraira played a very important role in the Göbekli Tepe story. This is an artist's impression of the airburst that took place over Abu Huraira. And interestingly, I have, of course, a lot of opposition from skeptics, but this was Michael Shermer, who edits the Skeptic magazine, who I've also debated. And after looking at the Abu Huraira evidence, even Michael Shermer had to admit that he needed to adjust his priors. In other words, his condemnation of the Comet Research Group and my work, adjust his priors in the light of more research like this and modify. It was nice to hear that from Michael. At least he had the capacity to admit that he could change his mind, which some of the other scientists I've had the misfortune to deal with, their minds cannot be changed at all. They're like Mount Everest, just stands there, cannot be changed or altered in any way. There we are. Sorry, I have a bit of a rant every now and then. So again, Atacama Desert, we're seeing vast patches of glassy rock in Chilean desert, exploding comet. The evidence just goes on and on and on, and it keeps on going on. Now, one of the things that's happened, and I hope that Alan will talk about this a little bit, is that the scientific opposition to the Comet Research Group has been so huge. There's been an attempt to cancel them, to cut them out of mainstream journals, to the point where they're getting tired of arguing with the editors of mainstream journals, and they've created a journal of their own, Airbursts and Cratering Impacts. It is peer-reviewed, and most of the very recent science on the Younger Dryas impact has been published in that paper. So I just want to show you that this keeps on going, that there is more and more evidence for it, and this is a little sinister. This is just a screenshot from a YouTube channel. Notice the way that YouTube gives us these warnings. We're not grown-ups, you know. We have to be told what to think by YouTube. So aware that the comet issue raises issues of climate change, YouTube feels compelled to tell us that the United Nations reports that climate change refers to long-term shifts in temperatures and weather patterns. Human activities have been the main driver of climate change. In other words, one of the reasons that the Younger Dryas Impact Hypothesis is being snubbed and attempts are being made to snuff it out is because it contradicts the present narrative that human beings are responsible for all climate change on this planet. I have no doubt that human beings are responsible for some climate change. But if we look back into the past record, we can see that much more radical climate changes have occurred at a time when there was supposedly no industry on Earth at all. So I think that's part of the problem, that this cataclysmic event which caused radical climate change was not caused by human beings. And that has led the establishment to try to marginalize this theory because it goes against a current prevailing narrative. So I'm just looking at, I don't want to read all of this out, but it's a fair summary of the evidence and counter-arguments against the Younger Dryas Impact Hypothesis. And then, of course, the gang of scientists who hate the Younger Dryas Impact Hypothesis, particularly including individuals like Nicholas Pinter, Andrew Scott, Vance Holliday, Mark Boslow. So it's interesting. In 2011, they published a requiem for the Younger Dryas Impact Hypothesis. They're washing their hands that we've completely destroyed the Younger Dryas Impact Hypothesis. It will never raise its head again. Here's its requiem. So weirdly, the same group of authors in 2023 are publishing another requiem for the Younger Dryas Impact Hypothesis. Like their first one wasn't good enough. They call it a comprehensive refutation of the Younger Dryas Impact Hypothesis. It's a rubbish paper from beginning to end. It's full of hatred and jealousy and envy that the guys writing these papers didn't make that discovery themselves. But the papers have been well responded to. Martin Sweatman from the University of Edinburgh has done excellent work rebutting the so-called comprehensive deduction of the Younger Dryas Impact Hypothesis. Lawrence Powell, very important work, Premature Rejection in Science, the case of the Younger Dryas Impact Hypothesis. This is a problem we have. I see it very much in archaeology because that's my primary focus at the moment, but I suspect it's right across the scientific world. The tendency to prematurely reject new ideas. The tendency to say, oh, here's a new idea. Let's look for everything we can find in it that's bad, and let's exaggerate that, and let's try and get rid of it. Wouldn't it be better when a new idea comes up if people said, let's look for what's good in it. Let's look for what we can see in this that might be useful, that might be helpful to understand our predicament of human beings. This destructive criticism within science, it has its place, but it allows very negative human emotions, particularly jealousy and envy, to come across and prematurely reject important scientific developments. So Lawrence Powell's paper is very important on this, and he's carried on subsequently. So, despite the hostility they're facing, the Comet Research Group are constantly coming up with new evidence which supports and reinforces their theory. It's like with all paradigm shifts. A paradigm never changes overnight. It has to be overwhelmed by new evidence, and not just a little new evidence, but lots and lots and lots of new evidence. And that is what is happening right now with the work of the Comet Research Group. So I don't think that I don't think there's a big problem in understanding why those ocean currents were interrupted 12,800 years ago. It was the Younger Dryas impact. What happened at the end of the Younger Dryas is much less well studied. Way back years ago, Sir Fred Hoyle in the 1980s proposed that the sudden end and the global warming that followed it, the sudden end of the Younger Dryas 11,600 years ago, might have been caused by another cometary impact, another bit of that fragmenting giant comet hitting a world ocean, sending a huge amount of water vapor into the upper atmosphere and creating a greenhouse effect. And then, of course, Robert Schoch has done excellent work on the possibility that solar activity was involved. I think it's hard to make the case for solar activity at the beginning of the Younger Dryas, But there's a very good case to be made for solar activity causing that sudden warming at the end of the Younger Dryas. I don't see why the Younger Dryas Impact Hypothesis and solar fluctuations shouldn't coexist side by side. The impact hypothesis primarily focuses on the beginning of the Younger Dryas, not on the end of the Younger Dryas. So I think we need to remain open to all of these possibilities while keeping fixed in our mind the realization that the Younger Dryas was a truly cataclysmic global event. It's interesting that the Younger Dryas did end abruptly 11,600 years ago, and as Randall said this morning, that coincides with a massive pulse of meltwater pulse 1b. And interestingly, the date of meltwater pulse 1b, 11,600 years ago, 9,600 BC, is exactly the date that Plato gives us in his Timaeus and Critias for the submergence of the lost continent of Atlantis. And I will return to that in my closing talk tomorrow. Now I'd like to invite Alan on stage, Alan West. Ladies and gentlemen, I'd like to introduce Dr. Alan West from the Comet Research Group. I've had the privilege of knowing Alan for many years and working with Alan. Alan appeared in the first season of Ancient Apocalypse, where we talked at length about the Younger Dryas Impact Hypothesis in the final episode. So we're going to handle this a bit like a podcast now. I'm going to interview Alan, unless you have some preliminary words that you want to say first, Alan.
Nope, ready for questions.
You're ready for questions? Okay. In that case, so Alan, some of your critics claim that giant comet impacts are exceedingly rare, that they occur only once every few million years, and that's too rare to have happened 12,800 years ago. Is that true?
Let's take a look at some of the evidence. Some of it Graham covered already, but I think some of this will be new to you. He talked about the Oort cloud, and of course this is our solar system, that's the asteroid belt. The Oort cloud is a gigantic cloud. It's so far out that we have trouble even seeing it with the largest telescopes that we have. But this is one of the objects that's in it. So, and you can see it's as big as Mount Everest. So,
keep it
sorry,
close.
Is that better? Okay. All right, so it's as big as Mount Everest, and I don't know how often any of you have seen Mount Everest, but let's take a look at the next slide, which will put it into perspective. Here's Sedona. That's the size of the object that we think hit at the Younger Dryas. So it's 120 miles across, about half the size of Arizona. So obviously that would cause a lot of trouble if it hit Arizona. So now, Graham already talked about the KPG impact, where 66 million years ago, 6 mile wide comet or asteroid hit the planet, obviously knocked out all of the dinosaurs. Oops, wrong one. And that's the size of the crater compared to the state of Arizona. So you can see the crater, which is off Yucatan, was larger than the entire state of Arizona. So it kicked up so much dust and debris that it basically caused what's called an impact winter, meaning that not only was there no sunlight hitting the ground for a long period of time, but it was just bitterly cold. So we think something like that happened with the Younger Dryas too. Now 790,000 years ago, not very long ago, this was the Australasian impact event. So another comet or asteroid broken up like that, hit in Southeast Asia. Chunks of molten glass were thrown across 10% of the planet. So it went from Australia up into Southeast Asia, into China, up in that area. So these things happened fairly recently. Of course, you've seen the Younger Dryas, heard about it. This is what we think happened, except probably it was larger than this, but a lot of these objects came in, blew up in the atmosphere in gigantic explosions, and it would have covered at least half of the planet. So these things, while the big ones are fairly rare, the smaller ones are not so rare. And we'll get into that in just a minute here too.
Yeah. So, as you say, I mean, the critics point out that these were all tens of thousands of years ago. And they say that you guys, the Comet Research Group, are making them seem more dangerous than they are. Is that true?
Well, let's look at the danger, and here's one of the figures. Every year, between 30 and 60 asteroids pass between us and the moon, and many of them are within the orbits of our satellites, the communication satellites. Your cell phones depend on it, your bank accounts depend on it, and these big objects are passing through. Now, they're not particularly huge, but they're dangerous. So, as Graham brought up, the skeptics asked, well, why worry? You know, they didn't hit us. And the analogy I use is it's a little like your neighbor comes over and says to you with a worried look on his face, somebody shot bullet holes through my window last night. And I say, why worry? It wasn't my window. So, so it's actually a near miss. If it could take out satellites, it could just as easily hit us. And when it does, here's the kind of things that can happen. This one was in 1908 in Tunguska, Siberia. It's an animation of what happened. This was a very small object, maybe 40, 50 feet across, knocked down 80 million trees. This is an actual photo. They're all spread out all across the Siberian tundra. This is what would happen if it happened over New York City. It's bigger than New York City. And this is an animation of what would happen if you were on the ground in New York City. So they say, why worry? Well, this is the reason that you should worry.
Yeah.
So this is Shoemaker-Levy, 1994, whacked into Jupiter. Now you think that looks awfully small, right? Small dots in there. But let's put Earth by one of the blemishes that it put on Jupiter. That blemish is several times larger than the Earth, and Shoemaker, the scientist who discovered it, said if that thing had hit the Earth, we'd have had 3 to 4 months of total darkness, just like the darkest night. No sunlight, no photosynthesis, plants not growing, bitterly cold. That happened in our lifetime. So we know that they hit planets, so the skeptics say, why worry? There's the reason to worry.
Yeah, absolutely.
Now, this is even more of a worry. This is the 2013 airburst over Chelyabinsk in Russia. These are actual videos of what happened. Blew the door off the garage, blew in the window, knocked the people over, blew in another window, knocked the people over. So that was a small one. That was maybe 30, 40 feet across, so not much to speak of, but dangerous. You know, not going to cause the extinction of the human race, but certainly would be bad news over Sedona or any other city around here. So now here's another one that's been extremely controversial. This is 3,600 years ago. There's destruction of the biblical city Sodom. Now, obviously, our critics jumped on that right away. Well, how do you know it was Sodom? Well, you know, in all honesty, we don't. We did look for, we thought, okay, let's quiet the critics here. We'll look for street signs. So we tried to see if there was something like Sodom Way and, you know, Gomorrah Boulevard, that kind of thing. Couldn't find anything, but that was 2 times hotter than the sun. And this was a small one. We think it's maybe 55 feet across. So let's take a look at next thing. This is a computer animation that we did. It's called hydrocode modeling. So in the computer, extremely sophisticated bit of software. It took me 2 months to learn how to use this software to do it. It was that difficult. So, and you can see here the asteroid that we model is 55 meters wide, so about 180 feet. The energy was more than most atomic bombs. And those are models of the city buildings, so watch what happens to them. The thing blows up, and there go the buildings. And so this is what the model said happened. So then when we looked on the ground, we found evidence to support that. So this is an artist's rendition of what the roof might have looked like. They had clay roofs, many layers of clay built around logs to hold them up. So look what we found here. This was a piece of that roofing material, so it's just seriously contorted. It was harder than concrete because it had been baked by the impact itself. It also flattened a 4-story palace. This is the foundation of the palace, and it used to be 4-story tall. Instead, all of this material was blown into the valley next door. The shock wave was so intense it actually stripped every building off the top of that hill that you just saw. So now this is top view of the city. About 20,000 people live there. Well, guess what our critics did with this? We published a paper. It was in the world's largest journal. You can see there 600,000 people in 200 countries downloaded this paper, which just shows you that if you write papers that talk about giant rocks from space blowing up cities, people pay attention, got their attention. So our critics, however, took them 4 years to do it, but it was a relentless campaign of trashing our work, calling it fraud, claiming that we manufactured the evidence, that it wasn't real. And so the editors finally got sick of hearing from them, and they retracted the paper. So what did we do? We, as Graham said, we published our own journal, put it in it. In the last year, we've had 300,000 people in 200 countries read our papers. So, now
bravo, bravo.
So it just shows you that you don't necessarily have to fight the critics. They tried to stop us, and we simply went around them. Mm-hmm. And so, you know, you can fight with them, and you know, that's you've heard the old story about don't wrestle with pigs. You know, the pigs enjoy it. So, well, this is a little bit of the same thing. We decided not to argue with the critics. We just went around them. So.
And I think your policy has been to constantly publish new information.
That's a good point.
Add to the evidence, rather than getting into these fistfights with extremely negative people. Just keep presenting them with evidence they can't refute.
That's exactly it. You know, the critics are very active on Facebook and Twitter, you know, trashing what we're doing. We've decided to take the high road. You know, we basically ignore them, which is the worst thing you can do to somebody who wants to cause you trouble.
Yeah. But
it's actually worked. So now, interesting, what else we can do is outlast them. So that's part of what we're doing now. Interesting story about this guy. This is Max Planck. The turn of the century, he came up with quantum theory, which is, you've probably all heard of that. It's a big thing nowadays, you know, quantum computers and all that. A lot of that came from his research. So Max Planck had an interesting idea because he was just met with intense criticism too. I mean, people trashed his work, and he was just trying to get the hypothesis out there. So what did he do? He came up with this idea, science advances one funeral at a time.
Yeah.
Okay, now, just to be clear, these are two of the late scientists who opposed Max, Professor O.B. Struction, Dr. Eno et al. So now, just to be clear about Max, he was not advocating shooting his critics, although I'm sure it occurred to him more than a few times. But nevertheless, the idea is that your critics die out, the opposition goes away, and people say, well, that idea made a lot of sense. Why were they against it in the first place? So we're intending to try and outlast our critics. And may not be in my lifetime or Graham's, but we figure the truth is going to come out eventually.
The truth will come out. So, your papers report again and again finding very unusual materials in the Younger Dryas boundary layer. Give us some examples. What are the most unusual ones?
Okay, well, this is the thing. The the critics attack us saying that what we're finding is not real. We had actually one critic accuse me of making these iron spherules in my basement and and salting them at these sites. So now those things, you can see they're sometimes smaller than an ant. So what does that mean? It got so hot that every car in the parking lot would have been turned into a pool of molten iron and plastic within less than a few minutes. So incredibly destructive. So we found lots of those at sites. We also found something called shock quartz. And you can see here, it's these small lines that are in there are called lamellae. They're actually fractures in the quartz. The quartz is the size of a sesame seed. And just to give you an idea of how much pressure is involved, this is the Washington Monument. So imagine this. Stacking 75 elephants on top of the Washington Monument, so 750,000 pounds per square inch. So just this massive amount of pressure on these tiny little quartz grains, and nothing on this planet except people and impact events can cause that. So now we also found nanodiamonds. You can see this is an animation of a virus. They're about the third of the size of a virus. If we took all the diamonds that we found in 60 some odd sites across the planet and put them into a single ball, it'd be pretty much bigger than downtown Manhattan. And these are actually images with a $10 million electron microscope of some of the diamonds we found stuck in the Greenland ice sheet. We actually had a crew go to Greenland. We took the ice back, melted it, and this was what was in it. So those are some of the things we're seeing. They're very unusual, and the critics basically say, oh, we're making it all up.
What about the high levels of radioactivity that you found at some sites, which I know your critics have disputed? What's your reaction to that?
Okay, let's take a look at some of the evidence here. So you saw this in Graham's presentation. That's the famous black mat at Murray Springs, just not very far from Fort Huachuca. This was one of the first sites that I visited, and most of our evidence is not only here, but in 50 to 60 sites across the country. Well, interestingly enough, that it was radioactive. I mean, not radioactive in the sense that it would kill you, but it was much higher than it should have been. So we published a paper very early on about this, and along with this is a mammoth leg bone from New Mexico, the same thing. The yellow staining is a uranium ore called carnotite. So this went viral on the internet. People were saying, oh my gosh, nuclear war 12,800 years ago. So we tried to talk them out of it. I mean, there was no evidence of nuclear war, but we're not sure what they had in mind, but we figured this might be something. So I suppose they thought the Clovis Native Americans had nukes. Now, if they did, that would give a whole new twist to the mammoth extinction. They simply nuked them.
Okay. So some scientists, Alan, they question your evidence. They say it's just regular terrestrial material, that you've misidentified it, or it's just a coincidence that you find it in the Younger Dryas boundary layer. What's your answer to that?
Okay, so let's look at Murray Springs again with this coincidence idea. So let's imagine that we could strip back the land and show what it looked like 12,800 years ago. Look something like this, probably not a whole lot different than today. So, but here's the difference. So there was a rain of those melted iron spherules of diamonds and other things, at 1,000,000 times the normal background. So now they're falling, to be fair, they're falling out of the atmosphere all the time because we have meteorites, small ones coming in all the time. So there's a small rain of this material, but this was 1,000,000 times greater. Mm-hmm. So let's put it back together again. So it all there. So could it be really a coincidence?
No.
10 million tons of spherules across the sites we've looked at. Those are just the ones we know about. 400 million tons of nanodiamonds. So is that a coincidence? You know, just simply impossible that it could be. The critics don't ever give up, you know, but that's still what they think. So obviously we think the YD impact did it, and that's the best explanation anybody's come up with so far.
So you also claim that human populations at around that time, 12,800 years ago, went through a massive decline. This is a very dramatic figure, as much as 2/3 of the people on the planet. I know your critics don't like that idea at all. Again, how do you respond to the criticisms?
Yeah, so here's some evidence for it. This is chert or flint, and you might know it. For the Native Americans, this was like Home Depot and Ace Hardware all rolled into one because they made tools out of it. So these are some of the incredibly beautiful spear points that they made out of chert. And curious thing is we found 11 chert quarries in the eastern United States. They were everywhere, but these are just the east. So they were in Virginia and Kentucky, Tennessee, and South Carolina. Then, not long after, or right around 12,800 years ago, they disappeared. I mean, they were abandoned. The chert was there, but the people weren't there. For nearly 700 years, nobody used any of those. Now, imagine if you're building a house and you decide, well, I'm going to do it, but I'm not going to go to Ace Hardware or Home Depot. I'll just stay home and build it. Well, you know, pretty hard. But that's what happened. So we found that 2/3 of the human population across at least the northern hemisphere, and quite likely the south too, vanished. So when you think about it, just imagine that if the person sitting on either side of you disappeared within a few days to weeks to months, they were gone. 2/3 of your family disappeared. 2/3 of everybody you know disappeared. What kind of effect would that have on civilization? It'd be something you wouldn't forget about. And we hear that in a lot of the stories about these disasters. It was a striking, stunning turn of events. So now we thought, let's be fair, what if it wasn't the comet? Now we think it was, but I came across one scientist who said, well, they just headed south for the winter. So now there are probably a lot of you that might do that too. You know, hey, makes sense, right? You're cold up in Michigan or New York, so you head for Arizona or Florida. So, well, we decided to test that out. The best estimate is there were a few tens of thousands of Native Americans in North America then. Not a lot, you know, wasn't heavily populated. So we decided to look and see. If there were tens of thousands, then you certainly would know if they all headed south into Mexico. You'd be pretty sure that there'd be some evidence of it, right? Well, we did. We looked, and we found evidence for 3 people, tens of thousands, and here they are. Yeah, these are the Clovises. 3 of them headed for Acapulco to sip margaritas on the beach. You know, it makes sense. It was cold up north, so they headed south. So no, in actual, all joking aside, there was no evidence for people, a massive migration to the south. What happened to them? They got killed.
Yeah, the question of extinctions. In the Younger Dryas Impact Hypothesis, you are directly implicating the event with the extinction of literally millions of mammoths, mastodons, saber-toothed tigers, and so on and so forth. Your critics claim that human hunting, it's called the overkill theory, did it, or maybe climate change. Why do you think it was a comet impact?
Well, let's take a look at the different possibilities. So first, here's what happened. There were tens of millions of mammoths, mastodons. That's the giant sloth that would have been 8 feet tall. So imagine one of those in your front room. His head would have touched the ceiling. There were native horses in North America, not the ones we have today, which were brought by the Spaniards. They were native here. They disappeared at the same time. There were saber-toothed cats, which were probably several times about the size of a small pony. This was called a dire wolf. It was about twice as large as any wolf today. There were camels native to North America, not the ones that are imported. There are a few around today, but they actually lived here back then. A giant armadillo that would have been taller than Graham, so not like the little ones you see today. And bison that would have been nearly 8 feet tall at the back, and they all disappeared. So you can't read it, but there are 4 main ideas that scientists have about what happened to them. So let's look and see how plausible those ideas are. First is they got too cold. So this is what's called the over-chilled hypothesis. But it really doesn't make any sense because these mammoths had been around for millions of years. They'd been through several severe ice ages that were colder than the Younger Dryas. So why would they have suddenly dropped dead with this last one? And so that doesn't make any sense. Another one they got was called the mammoth flu. So the idea is that they were susceptible to some kind of pandemic. So, well, you know, that seems reasonable. Animals get pandemics all the time, but does it make sense that a pandemic would have killed mammoths, mastodons, giant sloths, horses, camels, vultures, direwolves, giant armadillos all at the same time? No, just not likely. So that's called the over-ill hypothesis. The next one is they got skewered. So this is what Graham was talking about, overkill. You know, the Native Americans killed them off. Well, you know, we know they were hunting them. In fact, they were quite lethal hunters. These are some of their points there, and they used what was called, they had replaceable shafts for their spear points. You can see one over here. There's the spear point coming down and with the tip on it. And so here's what they would do, is they would just replace it like that. So they'd stab the mammoth, replace it, hit them again. So, I mean, that's pretty lethal. But here's the problem with the overkill hypothesis. They would, every man, woman, and child in every tribe, every one of the 10 to 20,000 people in North America would have had to have killed a dozen mammoths a day to cause their extinction. And so what about all the other animals? I mean, were they eating armadillos? Were they eating wolves? No. So by itself, that doesn't make any sense either. So of course, then we think they got fried by the comet. So, and that's called over-grilled. So now, that's the best explanation, but to be fair, all of the other ones, we think it was really a perfect storm of all things. I mean, when you have an impact event, you're going to change the climate. That's going to kill some animals. The climate change and other problems are going to cause pandemics. You know that the Clovis people were hunting them already, so we think all 4 of those are not mutually exclusive. They were all in play. But we don't think any of them would have happened if it weren't for the comet impact, which means that if it hadn't happened, you'd have mammoths eating your vegetables in your backyard and saber-toothed tigers to look out for when you went out for a jog. So we think the comet was the main factor, but all of the other ones were in play too. So.
Yeah, I've never been persuaded by the overkill hypothesis. No. Contacts I've had with hunter-gatherer groups in the world today, these are people who do not wipe out their food supply. No. They live in harmonious coexistence with their food supply. They never take it to that level, and it would have been the same with hunter-gatherers 12,000 years ago as well. Yeah.
It doesn't make logical sense to anyone except some scientists.
Who want to get rid of a hypothesis they don't like, yeah. One of their sort of supposed killer blows against the Younger Dryas Impact Hypothesis is the absence of a crater. They keep bringing this up. There's no crater. What are these guys talking about? Put that to rest.
Well, you know, one is, as Graham pointed out, when you have a lot of small objects hitting around, they're not likely to leave craters, just like a big one would. The one that caused the dinosaur extinction was one single huge object, so we think there were tens of thousands of small objects, so they're not going to leave much evidence behind. But there is some possible evidence. This is what the ice sheet looked like about 13,000 years ago. You can see almost all of Canada was covered. It went into the Great Lakes region, covered all of the Great Lakes, parts of Michigan. There was a 2-mile-high ice ridge right across the middle of Canada there. So now look what's happened just a few hundred years later. It's gone. And in its place is Hudson Bay, which you know, probably all of you know it today, huge inland sea in Canada. There's no evidence that Hudson Bay existed prior to this ice age. So what we've been looking at is this possibility. This is what's called a bathymetric profile. They used you know, sonar to look at the bottom of Hudson Bay, and there's this 250-mile-long feature with what looks like an impact rim around it, which is exactly what you get in craters. Big hole in the ground, kicks up a rim around the outside that's raised. Now, is that a crater? We really don't know. But this year, one of the things we want to do is we want to find out. So they've extracted a lot of cores out of Hudson Bay, and we think there might be evidence for a comet impact in it. We don't know, but we're going to find out. But that's what science is about. You come up with a hypothesis. We think that could be a crater. Now we've got to prove it. So.
If this happened today, we understand that a single small airburst might destroy a city. Tunguska would certainly have destroyed a city. But it wouldn't have much effect on the rest of the world. What would happen if we had something like the Younger Dryas debris shower today?
Well, it'd be bad, but let me go to let me kind of lead into that. So the question is, why are some critics so opposed to what we're doing?
Yeah.
And to be fair, it's only a few. You know, we give the group, and there are more than 100 scientists in the group, 15 countries, 55 universities. We give talks all the time, and by and large, they're like you. You know, they're receptive to it, and I'm sure all of you aren't necessarily convinced that this happened, frankly. I'm not convinced that we know exactly what happened either, but we want to find out. But the interesting thing is, question is, how did it start that there were that small group of these just virulent critics that we have? And we think this guy's to blame.
Yeah.
The man in black, right? You've heard of him? Actually, it started with the government. And one of our key scientists was high up in NASA for 20 years. He was a NASA section chief. And he told me that back in the 80s, when they first discovered the big impact into Yucatan, the government knew that they couldn't do anything about it. And they were starting to get worried calls from their constituents that, what can we do about these things? You got to do something about it. You got to stop it. And they couldn't. So what they decided to do was to just pretend that it wasn't real. They had the public fears about the impacts. They decided to just deny, just say, don't worry, there's no problem. We've got it under control, when they didn't. And he said the problem was that there were some small group of people, mostly in the government, that knew they were lying about it, but then it became the doctrine. It got out there, people began to believe it. The people down the line said, and most of, to be honest with you, most of our critics either work for NASA or they work for government organizations that depend on NASA for their funding or for their research facilities. And so his thought was that became this institutional position that there was no danger from these things, and just tell people don't worry because they couldn't stand the truth, so don't tell them. So I think that's how, so now to be honest, it's gotten better, but let's just see how much. So comets and asteroids every year, the budget is $150 million to look for them, and they put up a few satellites to try and see when they're coming. But compare that to this one submarine, nuclear submarine, 3,000 million or $3 billion, 150 million versus 3 billion. There's something wrong with this picture. So now I think if NASA suddenly saw that there was a comet coming in that was going to hit one of their nuclear submarines, and they'd probably be more interested in spending money, but at the moment they aren't. So.
But the question is, if just hypothetically, if something like the Younger Dryas impact event were to happen today, not a massive big impact that would threaten all life on Earth, but a series of airbursts, as you're proposing 12,800 years ago, what would be the consequences for our civilization today?
Let's exactly, you've shown what happened during the Younger Dryas, and we've seen some animations too of a lot of these small objects hitting. Now, that was a big event, but let's say that we had a smaller one, what would happen? And it doesn't look good for our technological society. They could take out our communication satellites, no cell service. If they came in, multiple airbursts like that would fry transformers, overload the grid, burn out the transmission lines, cities would go dark, no TV, no internet. Oops. So our entire civilization would go dark. Well, that's not good. Yeah. And that would be for a relatively small one. Now, to be fair, that's not likely to happen tomorrow, but the odds are above zero. In fact, they think that Tunguska-like events might happen every few hundred years. So, but then they're more likely to happen over the world's oceans, but they could happen over a city. And so we really need to do something about them. And it doesn't look like our government is very motivated to do that. They more likely build nuclear submarines than to do what they need to do to fix these things that are coming out of space. And the bad news is they know where the big ones are, but they don't know where the ones are that are as wide as this auditorium. They only know a small percentage of them. And the trouble is they often don't see them coming until they're gone. In other words, they pass between us and the moon and they say, oops, there it went. Well, that's not very good. So it's something to worry about. But the thing is, we can do something about it. They can put up satellites that can look at the entire sky. They can see these coming. There's some remediation policies that they already know about they could do. But are they going to do it? I'm afraid that's not likely.
Yeah. So we've got this background of virulent, extremely hostile, very personalized criticism of the Younger Dryas Impact Hypothesis. And yet you continue to present new evidence and build your case stronger and stronger. How long do you think it'll be before the YDIH actually is widely accepted?
Yeah, I wish I knew, but it might not be in my lifetime, might be the next generation. Generally, paradigm-shifting ideas can take 30, 40, 50 years to finally make it into the mainstream. The old idea of science advances one funeral at a time, so our critics have to die off before it does. But we're really making progress, and in the last 5 years, our papers have been read by 1.5 million people in 204 countries. Wow. Our critics, they've been read by a few thousand people, mostly in the United States, mostly their friends. So when you look at that, we're making progress, but it's slow. But I will say that one of the major reasons we've been able to do that is because of donations from people. Thousands of people have donated to help us do this. And that's been essential. And one of those people is Graham. He's donated from his personal to do that. Another is a guy sitting in the front row here named Eugene. He came to, he heard Graham talk sometime, and these two are part of our angel donors, we call them, because we can't get money from the government. So we've really depended on donations. We have a lot of people who donate $1 month after month, $5, $10. They're just as valuable to us as the big donors because they all add up when you get thousands of them. So all together, so yeah, let's give a hand for Graham and for Eugene here. And quite likely some of you might be donors too. You know, we've been doing this for a few years, and we take good care of your money if you do donate. We don't take any salaries ourselves. Every single bit goes to pay for these expensive microscopes. The electron microscope, some of the images that you saw were taken with equipment that costs us nearly $300 an hour to rent. So we have to pay for that out of donations. So we're getting it done. It's slow but steady, but as Graham will attest, when he started with this, almost nobody knew about the Younger Dryas hypothesis. That's changed now because of his books, because of his talks, just like this one. Thousands and thousands of people across the planet know about it who did not know about it before. Now, and we've always thought that this would have to be a kind of a groundswell movement, that people pressure governments to do things. Government generally don't do them unless they're pressured to do it. Unless they want to pay their billion-dollar donors and for their, pay them back. But at any rate, so we're making progress.
Definitely. So there's just a couple of short questions left. Absurdly, your critics claim that everything about the Younger Dryas Impact Hypothesis is wrong. Do you think any of it actually might be wrong?
You know, if the critics ask us, or even reviewers, or just like Graham ask us that, we'll be the first to admit that we don't know everything about this. You know, you probably heard the old story. They asked 3 blind men to describe an elephant. So the first one grabs the trunk, says, "Oh, it's like a fire hose." The next one grabs the leg and says, "Nope, it's like a tree." And the third one grabs the tail and says, "It's like a rope." Well, we're at that stage. We really don't know how to describe this elephant of an impact, and there are a lot of things that we don't know about it. And as Graham talked about too, it's entirely possible that this huge comet that came in went on and smacked into the sun. If it does that, there's just a massive solar eruption that comes out. If that was aimed towards Earth, we could have gotten hit with what's called a CME, coronal mass ejection. So also there could have been just other things at the same time. A supernova went off at the same time. Well, they tend to bathe nearby stars in deadly radiation. So, and what they do is, even though they don't put out a lot of pressure, they put out a wave that goes through space. And even though it's subtle, it's enough to very gently kick comets out of their orbit. So what happens when there's supernovae, there are often extinctions tied into them. And so we think that maybe a supernova went off, pushed the comet in that hit the Earth. So there's more than one thing that it could be. And actually, because of the funding that we've been getting, we're actually looking in ocean cores for evidence of supernovae, evidence for coronal mass ejections, for evidence of other things that could have happened at the same time. We're pretty certain there was an impact. That part we're clear about. But even then, we don't necessarily know what it was or where it came from. There are certain objects that'll come in from deep space. I don't know if you saw this. There was this object called Oumuamua that came through. It was this spindle-like object that shot through the solar system. It came from deep space, shot through our solar system, and kept right on going. Well, who knows? It could have been an object like that. So that's one of the things we're looking for in these ocean cores too. Is there evidence that whatever this comet was maybe was from deep space? It wasn't from our system at all. So So we'll be the first to admit we don't have all of the answers, but we're looking for them. And in spite of the critics, we plan to keep publishing what we find.
So your critics are, this is the last question really, your critics are very noisy. They do seem to have mastered social media quite effectively to make this a multi-pronged attack on you. Listening to their noise, you would get the impression that there's a lot of them. Are there actually a lot of them? How many people are we dealing with who really want to stick the knife into the Younger Dryas Impact Hypothesis?
Well, there are what we call the loudmouth critics and the quiet critics. Mm-hmm. So the loudmouth ones like to do it on social media, but then once again, I'm sure all of you know about social media. One of the things, if you want to know how important something is, you look at how often it's shared, how often it gets likes. Well, we look at the criticism we get of the Younger Dryas, and generally there are maybe 10 or 20 likes or shares. So when we put things out, it's considerably more than that. The same with Graham. When he puts something on his Facebook page, he gets a lot of likes and shares. Well, that tells you how popular it is. So I think our critics are very vocal, and unfortunately they do have a fair amount of sway. You know, they're keeping a lot of our papers from getting accepted. We get things like a reviewer says, this journal should not publish this paper in a million years. It's just pseudoscience. There's nothing to it. It's all made up and bogus. Well, then the editors look at that and they reject the paper. So that's why several years ago we set up our own journal. So we just, okay, you're going to close this door. We're going to go around and just do it anyway. So they're not having much effect. You know, they had more effect. At one point, we had one paper that was rejected by 6 different journals, one after the other. And we finally said, that's enough. We set up our own journal. We published it in our own journal, and we followed all of the same rigor that journals follow. We had it peer-reviewed by experts. We listened to what they said. We changed it, and we published it, and lots of people are reading them. Yeah.
Well, congratulations on the work that the Comet Research Group is doing. I think it's incredibly important work, and I would urge everybody, keep your eyes and your ears open for future developments with the Comet Research Group. And there are many projects in the world today that deserve support, but the Comet Research Group is definitely one of them, because what they're looking at has implications for the whole of life on Earth, for all of our futures and the children in the future as well. So thank you. Thanks, Alan. Well done. That's really good.